All right, so for this topic, we're going to be talking about the discriminant and what that means in terms of the shape of a graph of a parabola. Also, we're going to need our old friend, the quadratic formula, and here he is. So, first of all, what is the discriminant just algebraically? Like if I'm going to write it down, what is it? Well, it's this part right here of the quadratic formula. It is the b squared minus 4ac. That's the discriminant. Okay, cool. What are we going to do with it? Well, notice if you graph a parabola, first of all, it could be either facing up or down. I'll just use up once for now. There's a few ways a graph could look. We could have a graph that looks something like this. We could have a graph that looks something like this. And we could have a graph that looks something like this. Okay. So what the discriminant can do is it can tell us before we even graph the parabola which of these is going on. And you know what? I'll go ahead and throw up the ones that are facing the other way. So a parabola could also look like this. It could also look like this. And it could also look like this. So the thing is that while the discriminant doesn't tell you whether the parabola is facing up or facing down, it tells you the same thing about each of these graphs. So if we look at this, notice that there are, for each of the graphs here, for each of the parabolas, this one here has 2 points at which it hits 0, at which points it intercepts the x-axis. Likewise, this one, which is facing down, also has 2 places at which it intercepts the x-axis. Well, if you look at the entire quadratic formula, remember that what this does is it gives you these 0 places. And in the formula, we've got negative b plus or minus this whole square root. So we've got some number. We're going to add an amount to it, and we're going to subtract an amount to it. And so we're getting these 2 points right here. Now that is, of course, assuming we actually get an answer out of this square root. So what I mean by that is, well, if inside the square root this whole thing is positive, if b squared minus 4ac is positive, so I'll put that here, if the discriminant is greater than 0, you're going to have 2 intersection points on the graph. Because you're going to have some value plus an amount, whoop, some value minus an amount, whoop. And so you get 2 results there. Okay, well, what if the discriminant actually equals 0? What if I plug in b squared minus 4ac and the whole thing comes out to equal 0? Well, you're going to have negative b plus 0 and negative b minus 0. So you have the same thing twice, which is really you're just getting the same thing. You don't get 2 different 0 points. You get 1, like over here. Notice that for both of these graphs, there's only 1 place at which the graph equals 0. It's right there. And this is going to happen when the discriminant equals 0. Since the square root of 0 is 0, I add it, I subtract it, nothing changes. We don't get any additional 0 points. Okay, well, what happens if the discriminant is negative? I plug in all these values, b squared minus 4ac, and I get a negative number. Well, recall that when you do the square root of a negative number, you actually get imaginary numbers. And imaginary numbers aren't on these graphs at all. So just to emphasize, this is called the discriminant. We'll label that there. And so if the discriminant is less than 0, if it's negative, there are no zeros, no intersection points. And you can see that for both of these, regardless of which way it's facing. This graph starts up here in space, and it just goes up, and it never touches this x-axis, and it never will. Same for the bottom one here. It starts down here and just goes down. It never has a chance to touch that x-axis. So that is what the discriminant is, and it's a great shortcut before you go through all the work trying to find some zeros. You can just look at this, and you'll already have an idea of how many zeros you should have and what your graph should be looking like. And that is the discriminant.